state the elementary row operation and then describe how it affects the determinant. And so we're comparing the two 2x2 matrices A and B here. And the first thing we want to do is describe or identify that row operation. So describe the elementary row operation. And so we can see, looking at these two matrices or comparing A to B, that the rows are interchanged. Right, we swapped our rows. We can say that the first row is put into the second row's position and the second row is put into the first row's position. And if we wanted to describe this as an elementary matrix, how we want to think, how does this row operation affect a 2x2 identity matrix? You can say that E here is defined as 0, 1, 1, 0. And again, it never hurts to check here. And if you're unsure, do I have the correct elementary matrix? Because it is going to be important as we go, especially with theory. You want to make sure if I left hand multiply matrix A by this elementary matrix that we just defined here, am I going to in fact get matrix B? And this one's nice and cute and quick here. We have 0, 1, 1, 0 multiplied by A, B, C, D. Right, and apply that row column rule. So first row, first column, so you have 0 plus C, and then 0 plus D. Second row, we have 1 times A is A plus 0, and then D plus 0, and we can see, oh, not D, that should be B. That's what you get for, or what I get for rushing. But we can see here that we do attain the matrix that we were looking for. We have C, D, A, B, which is matrix B. So we are all set. So we know, again, comparing these two matrices here, that the rows are being interchanged, and we've defined the elementary matrix for this row operation. And so then to prepare us for our next section, we want to go ahead now and describe the effects on the determinant. So the determinant of matrix A, by definition, is A times D minus B times C. And then we have the determinant of matrix B, which is going to be C times B minus A times D. And we want to try to rewrite this to attain a form of the determinant for A. And we can easily do this if we simply factor out a negative. I have minus times A minus CB plus AD. If we switch the order of our terms, we can see, hey, that's negative A times D minus B times C, which is the determinant of A, or minus the determinant of A. So we can see here that when we interchange rows, the sign of the determinant changes. So that's going to be an important property to remember as we proceed.